I'm excited for the video I have to show you today. Implementing VXLAN is a time-consuming process and it takes hours to do. So instead, let's look at shortening that by utilizing Python scripting and the NXAPI on the Cisco Nexus 9000 series switches and reduce that from hours down to minutes. And I'm going to show that to you in real time. Hi, I'm Rich. Welcome to the Rich Tech Guy channel. And if you know anything about VXLAN, you know that it really is a challenge and a time-consuming process to implement manually. Not only that, it's error-prone as you're hopping from device to device and making sure you're getting the configurations to match across all those devices. So instead, let's automate this process utilizing the tools and resources available through Cisco DevNet and the Nexus API on the Cisco Nexus 9000 series switches, and create that automated process that runs in just a matter of minutes. And if you don't know anything about VXLAN, I would encourage you to go take a look at the link above my head or down in the description below. And that link will go to some videos that I've made about VXLAN and explaining it out and explaining the configuration steps. So let's get into this. All right, to recap, what it takes to deploy VXLAN is, first of all, once you get all your L3 infrastructure laid out, is you're going to deploy a link state routing protocol such as OSPF as your underlay routing protocol. And then you are going to configure BGP across your infrastructure and set up your spine switches as your route reflectors. After doing that, you are going to create a multicast protocol and you're going to assign the multicast specific traffic to VNIDs. And then you're going to create your VLANs, or if you already have VLANs created, you're going to take those VLANs and you're going to assign them to the VNIDs. After that, you are going to create the NVE interface, and you're going to have that all set up so you can start encapsulating VXLAN traffic. You're then going to turn BGP, which at this point is probably just a unicast BGP setup, into a MP BGP, multi-protocol BGP, by configuring EVPN. And then you're going to take your downstream devices and make sure they're assigned to the correct VLANs, so that way they are able to communicate across your VXLAN network. And finally, after all that is said and done, you're going to smash the like button so the YouTube algorithm knows how awesome this video is. And also, if you haven't subscribed, you can go ahead and subscribe too. But anyways, if you go through all of those steps and you get that set up just right, then you're going to have VXLAN running. Now this is this is a defined process. So what that means is that you can define the steps and you can automate that. Now if you're working with Cisco Nexus 9000 series switches, or actually just Cisco switches in general, you can use the resources at developer.cisco.com and access Cisco DevNet, and there's all sorts of training and libraries available for you to be able to work with the automation processes. So let's go take a look at DevNet, but then I'm going to show you a little bit of a shortcut when it comes to the Nexus switches. All right, so I'm here on the Cisco DevNet website, and for VXLAN, we're likely going to be working with data center devices. So I would go into technologies, and I've already got data center selected in here. You could go to networking if you're trying to work with the Catalyst line of switches. But since we're working with Nexus, I'm going to go data center and then NXOS. And right here you go to the Open NXOS page, where at the very top we've got some learning tracks on how to program the network, and so you can go through these tutorials and work with that. There's also some more information as you scroll down here. And the last couple of things here I'm going to bring up are developer tools, which is where you're going to find the documentation for working with these switches, and also the ability to test your code in the NXOS Sandbox. So if you don't happen to have a couple of Nexus switches lying around, you can test your code there. I mean, it's only like a $50,000 switch, so anyways. But yeah, you can go ahead and test it on the NXOS Sandbox. But let's go into the developer tools. And in here, you're going to have a lot of information about the opening, working with, actually that's the DevNet Sandbox. I've got over here you can go into the APIs, the model-driven programmability. So we got our get started here about OpenNXOS. You can talk about NXAPI references here, where we can go into the NXAPI REST API, and here's all the documentation that we can pull up on that. And there's also a section on Python and how to incorporate Python scripting with Nexus switches. All right, but as I said earlier, if you're working with the Cisco Nexus 9000 series switches, there's a little bit of a shortcut you can take. You can actually get the switch to tell you how to program it. And I'm going to show you how to do that. Now, the first thing you're going to do is on that Nexus 9000 switch in the CLI, you are going to type in the command under the configuration commands. You're going to type in feature NXAPI. Once you've got that command active, and actually you are going to need that command active because that is how you're going to use APIs to interface with the switch. But once you do have that command active, you can actually have the switch show you not only how the commands are sent over to the switch through the APIs, but it will also show you the response you're going to get back. So let's take a look at that. All right, so here is the shortcut. Now, once you've got that feature NXAPI turned on this switch, what you are going to do is you're going to take a web browser and you are going to point it at the management interface IP address. And you're going to be met with a login prompt, so you have to log into the switch as if you were logging in directly to the CLI. But with that login prompt, once you've accomplished that, you're going to be taken to this screen. And on this screen, you are going to have a little box here where you can enter in the CLI commands, and then we're going to show some information down below. Over here on the side here, we're going to define the method. So you can use the NXAPI CLI, NXAPI REST, or you can use RESTconf. For the purposes of what I have done is I've utilized the NXAPI CLI. And then you've got the message format. There is JSON, RPC, XML, or JSON. I just used straight up JSON. That was easiest for me. And then you're going to have command type. So when I was writing this out, I had to create two different sets of interface codes because I used the JSON command type. The first is CLI show. So I would use this if I wanted to get data off of the switch about what the switch's configuration is. And the other one is CLI conf, and that's for when you are going to try to actually push a configuration onto the switch. So like if I go on to CLI show and I want to type in show IP interface brief. Already in this request field, it's showing me the JSON configuration that it is going to send over to the switch. And then what I can do beyond that is, let's skip over Python because we really need to be on Python 3. If I click on the Python 3 tab, it is going to actually show me the Python code necessary to send that command over to the switch. Now, if I want to utilize other languages, such as, say, Java, there is all of the Java code. Or I can say JavaScript and that, or I can even go with Golang. So if we look at it from Python 3 perspective, I would just take that. Now, it will indicate you got to modify some stuff here, so you got to put in your user ID and your password, and so on and so forth. But if I click send, it's going to send that command, show IP interface brief, off to the switch, and then the switch is going to reply back. And so now it's going to show me the response back. And actually it is saying it's a invalid config because I misspelled brief. All right. So let's try that again. So now if I sent it, all right, I'm going to get the response back. And now it's showing me the interfaces that have been configured with an IP address and what the state of those interfaces are and what the IP address is configured on those interfaces are. So this is great, and it comes back in this JSON output, so you can take that and you can parse that data and use that for your code to actually be able to implement that and find out if you've got the correct configuration or if you need to make a change in the configuration. Now I said the other way to go about doing this was through the CLI conf. Now when you select CLI conf, you're going to get another thing here, and that's error action. All right, so what error action is going to do is it is going to basically say, hey, if we encounter an error while we're trying to push this new configuration onto the switch, what do you want me to do? So your options are, you can stop on the error. So you hit the error and the code just stops. It's like, nope, we're done. You can continue on error, where you just basically ignore that the error happened and keep on going. I'm not quite sure why you would want to do that, but you know, it's an option. And then you can roll back on error. And this is the one that I prefer, because that way I can, if I see the error message come through, it'll roll back the config, and then I can go figure out what happened and then make adjustments to the code and re-push, so that way I'm working on fresh configuration. Now in this particular instance, I'm going to do a different type of command, because the show commands, that was for the CLI show. For CLI conf, let's say I want to deploy the OSPF feature onto the switch. So I can type in feature OSPF, and again, it's going to show me the command. Now what if I want to show or do more features than just OSPF? I want to also enable BGP, because we're going to use BGP for VXLAN. So I'm going to type in on a new line, feature BGP. All right, and if you'll notice on the input here, it's showing how it's going to separate out the commands. It uses a semicolon. Very important thing I discovered in my working with the code and testing it out is you do not put the semicolon directly at the end of the command, or the switch will think it's part of the command. So you have to put a space and then a semicolon and then the new command. And again, we go over to Python 3 and it will show the Python code necessary to send the config in order to push that command out. So when I hit send, it's going to send that command out to those two commands out to the switch, and it's going to give a response. And it's going to be a little bit different from the show response. The show response was showing you the data that it was receiving back from the switch, showing the configuration. Because we're pushing the configuration out to the switch, what it's doing here is it's basically saying, hey, was this successful? Did it fail? So this is saying, okay, these commands were sent and they were successful. One of the reasons why I wanted to show you the multi-line configuration is because if you're configuring an interface on the switch, or maybe you're configuring BGP, you're going to go say router BGP, your autonomous system number, say 6500, and then you're still going to do a bunch of commands below that. So you need to be able to send all those commands at once and as different lines. Otherwise the switch, it's going to send the first command, router BGP 6500, and then you're going to send the next command, say the source interface. So your loopback IP address is the source interface. If you do that separately, the switch is going to error out on the second command. So you need to have the commands together, so that way it'll send the first command, router BGP 6500, and then it will send the second command of the source interface. So this is really an amazing tool that Cisco has programmed into the Nexus 9000 series switches. All right, let's go take a look at the code I did, and then we're going to demo that code. Okay, so here is the code I wrote for actually doing this command. I'm going to do a brief overview and a brief walkthrough, and then we're going to demo this code. Now, the way I've got this set up here is I've actually got multiple Python scripts running here. And this is the main one. This one is titled Deploy VXLAN. And so what this does is, first of all, it gets all of its information for the switches and your VXLAN environment, all of the variables that you're going to need. You are first going to configure in this JSON file called config.json. So this is your config file. And this file is going to essentially go over what's happening with these switches and the interface configurations that you are going to utilize in order to access them. You're going to configure your the VLANs, the underlays. You're going to assign the VNIDs. As part of this code, I do have a whole README file written explaining the config file and how you need to set this up, as well as I will be providing a config file template for you to utilize. And then, of course, we're going to go into the VXLAN Anycast MAC and so on and so forth. So we've got our config file set up. Now we're going to go into this deploy VXLAN, and it's going to run, and it's going to do some checking of the data that we've got, and then it's going to start calling the other Python files. It's going to be calling, say, the Nexus features file in order to enable the features on the Nexus switch. It's actually, all of these files here are going to utilize this file called NXOS call. And NXOS call is essentially that code that the switch was telling me about. Only instead of actually inserting the commands, I just put a variable space there, and so I'm going to feed it the variable with the necessary commands. So I've got the, and I've got a couple of versions of this. I've got the NXOS API, which is first just to be able to interface with the switch. I have the NXOS show command in order to run the show commands, and then the config command. And then I've also got an NXOS result, which will catch what comes back from the switch. All right, so again, we're going to work through the steps. So I've got a create underlay file, which is going to configure the OSPF. I have a create BGP overlay, which is going to conduct the BGP handling. Multicast file, so this one's going to work on the multicast portion. And as it runs through, and it will basically just loop through on every switch in the environment. So going back to that config file, you're going to have every switch listed out in your config file. And it's just going to loop through and run the configuration through on every switch and deploy VXLAN. So let's run a demo of that, and I'm going to show you in real time how I'm going to deploy VXLAN across 3 Nexus switches, 2 spines and a leaf, and we're going to do this in a matter of minutes. All right, before running the demo of this program, I am going to first just quickly show you what the environment looks like. I've got 3 Nexus switches. I have 1 spine leaf and I have 2 leaf switches. Attached to each leaf switch, I have a Linux system, which are configured to be in the same VLAN, which means that they will translate to the same VNID. So what I'm going to do is I'm going to have those 2 Linux systems start pinging each other. Initially, it's all going to fail, that the pings won't work because we don't have the VXLAN in place. And then I'm going to run the VXLAN program and let it do its thing. And at the end, the expected result is that we'll have network communication between the 2 Linux systems. All right, so in this environment I've got set up here is we have the 2 Linux systems here that I am SS staged into, RTG server 1, RTG server 2. Notice due to inconsistency in configuration. I have one in all caps, the other in not all caps. So that's why we're automating this stuff, so we can get better consistency. And these two will be, what I'm going to do is I'm going to have them pinging each other. As I said, they are going to be in the same VLAN, so they should be associated to the same VNID. But because we don't have that connectivity set up yet, the pings are not going to work. So let's start by having RTG server 1 ping RTG server 2, and that is going to be at 172.20.10.102. And we've initiated the ping and nothing is happening. On the other side, we are going to ping RTG server 1. And so that is 172.20.10.101. And we have initiated the ping. So now we are going to execute the Python script and let that run. And once it's all done, we should have connectivity and we should start seeing traffic flowing between the two Linux systems. So here we go. All right. So it is now reaching out to the first leaf switch, and initially when it starts talking to the switches, it tends to run a little slow. But once it starts getting some responses back, then it begins to pick up in speed. Right now it's just blasting all these features out to the switch, and you know that's quite a lot of commands it's feeding through. All right, so now we're running through our configuration, and it's created the OSPF underlay. It's checking its LLDP to find its neighbors, and now we're creating the VN segments and creating the switch virtual interfaces, assigning them to a VRF, and now editing BGP to include EVP configurations. And we are on to leaf switch 2. So we're going to run through this exact same process with the second leaf switch. Again, this can take a while, just through some of the responses back. It might take a little bit of time, but we will get that running through here. Already though, as I said, we've got one switch done, so we are definitely saving a lot of time here. And we're just going to keep on running through this, checking the LLDP neighbors so it can start establishing some relationships there, and boom, now it's off to configure the VXLAN on leaf switch 2. And creating the switch virtual interfaces. Okay, so now it's done the 2 leaf switch. Now it's moved on to the spine switch, and it's going to be running through same configuration here. We're going to just let it run here. Okay, we're creating OSPF. It's establishing its OSPF neighbor relationships, and once it's done with the spine switch, we're going to start seeing some pings flowing across. So configured the spine switch, and there we have it. We have pings. We've got traffic flowing. Our 2 servers in the same VNID are now able to communicate with each other. So as I said, this was in a matter of minutes. This is a configuration that if you were to just sit down and type in all the lines, it wouldn't go very far. So. All right, and there we have it. VXLAN deployed in a matter of minutes. Okay, saving some time. Now, I got one more thing as well. I have taken all of this code here and I have placed it into a GitHub repository. So I've posted the link down below to the GitHub repository. If you got a couple of Nexus switches lying around, or maybe you want to play around in the DevNet Sandbox, or maybe you've even got Cisco Modeling Labs available to you, and you want to check out this code and play around with it, go to the GitHub repository and check it out. Also, down in the description below, I've posted some links to some resources to help with coding and developing. So those are affiliate links. Do with that what you will. And, go ahead and hit that like button. If you like this video, hit the subscribe button if you're not subscribed to this channel. And comment down below, what's your experience with coding and working with the Cisco APIs and DevNet? This was a bit of an undertaking for me to do this project, but if you like this, I'll look for more projects that I can do and demonstrate. And choosing a life in tech is choosing a life of always learning. So keep improving, keep studying. I'll see you in the next video. Thank you.